All right, let's talk about garbage, stinky, rotting food waste. Now, what if I told you that you could take that exact same foul-smelling municipal trash and transform it into high-value agricultural protein? Sounds a little bit like magic, right? Well, it's actually pure science, and the secret behind this whole operation is a tiny powerhouse called the black soldier fly. So let's jump right into this explainer and see how we can literally turn trash into treasure.
Here is our roadmap for today. We're going to start with the feed and waste crisis, then meet the black soldier fly itself. After that, we'll break down its biological engine, map out a step-by-step farming blueprint, look at the economics and profits, and finally, discuss the future of sustainable agriculture.
Section 1. The Feed and Waste Crisis, Uncovering the Costly Challenges of Modern Agriculture. Okay, to really understand why this insect is such a game changer, we have to zoom out and look at the massive problems in our food systems right now. On one hand, we have overflowing municipal food waste. On the other, highly unsustainable, wildly expensive livestock feed. I mean, traditional commercial feed for fish or poultry will run you about 110 rupees per kilogram. But black soldier fly larvae? Just 30 rupees a kilo. If you replace just your livestock's evening feed with these larvae, your daily costs drop by 80 rupees. Over a standard 8-month aquaculture cycle, that translates into absolutely massive financial savings for a farmer.
But the financial cost is really only half the story here. The so what on a global scale is that by the year 2050, our global population is going to hit around 9.7 billion people. There is just no way we can scale up traditional, carbon-intensive animal feed, like conventional soya or fish meal, to feed all those people without completely wrecking the environment. We desperately need a solution that takes organic household waste out of our landfills and uses it to secure our global food supply.
Section 2. Meet the black soldier fly, nature's ultimate recycling engine.
So, we need a natural biological solution, right? Enter the black soldier fly. Now forget what you know about the pesky houseflies buzzing around your kitchen. This specific insect doesn't bite, it doesn't sting, and it doesn't carry diseases to humans. Instead, it acts as this brilliant natural recycling engine. It safely eats all that organic waste and converts it into pure nutrition. We're talking larvae packed with about 45% protein and 30% fat, plus a 25% mix of carbs and calcium. That specific nutritional makeup is exactly what you need to accelerate weight gain in livestock.
And the health benefits for the animals? Phenomenal. When you feed these nutrient-dense larvae directly to fish, poultry, sheep, or pigs, it actively boosts their antimicrobial immunity and drastically improves gut health and digestion. For cattle, it can actually increase milk production. For poultry farmers, it enhances egg-laying rates, improves crossbreeding vigor in hens, and, this is super interesting, it completely eliminates the stress-induced habit of feather pecking. Simply put, your livestock just grow healthier and heavier.
Section 3. The Biological Engine, Understanding the 4-Stage Life Cycle.
So how exactly does this biological engine work? It all happens in a really fast 45-day life cycle. It starts with a short 3 to 5 day egg incubation, and then we hit the magic window. That's the 13 to 19-day larval stage. This is when they voraciously eat the waste and just grow and grow and grow. After that, they go into pupa dormancy for 10 days and finally emerge as adult flies. The craziest part? The adult flies don't even have mouth parts. They literally cannot eat. Their entire 5 to 8 day adult lifespan is dedicated solely to mating and reproducing.
And wow, do they reproduce. A single adult female fly can lay up to 1,000 eggs before she dies. 1,000. That insane reproduction rate is exactly why this works as a business. It guarantees a massive, scalable, and continuous supply of larvae.
Section 4. The Farming Blueprint, Turning Organic Waste into Valuable Protein.
Let's get practical. How do you actually farm these things? It's really a simple 4-step process. First, you gather your organic waste. This could be municipal waste or spoiled fruit and veggies from local markets. Second, you take those hatched eggs and introduce them onto some moist bran over a mesh net. Third, keep it warm and humid. You want a temperature between 28 and 35 degrees Celsius. Finally, after 15 to 19 days of them chowing down on the waste, you harvest the plump 1-inch larvae.
You might be thinking you need some giant, high-tech industrial facility for this. You really don't. The essential equipment is incredibly accessible. You just need breeding boxes with mosquito nets to keep the flies contained. For egg laying, simple corrugated cardboard flutes held together with rubber bands work perfectly. You can use repurposed plastic cooler trays for feeding. Add in some basic moisture and temperature meters, and you're good to go.
Oh, and if you want to scale up, you'll eventually want to grab some small drying chambers and grinding machines. Now, if you are going to do this, here are a few expert tips to keep your yield high. First off, keep their feed moist but never soaking wet. Nobody likes a swamp. Second, keep them out of direct sunlight and heavy wind, which can actually be fatal to the larvae. Third, and this is a pro tip, if you want faster growth, source high-protein waste. Chicken intestines from local butchers are fantastic for this. Lastly, when it's harvest time, make sure you thoroughly wash the larvae to get rid of any leftover fruit or veg waste before feeding them to your livestock.
Section 5. Economics, Processing, and Profits. The financial reality of insect farming.
All right, let's talk money, because the economics here are fantastic. If you just sell live, raw larvae directly to local farmers, you're looking at a steady 80 to 150 rupees per kilo. Not bad, right? But if you process those larvae, using those drying chambers and grinders we just talked about, you can create a branded, shelf-stable protein powder. That processed powder jumps to a massive premium, selling to retailers for anywhere between 400 and 700 rupees a kilo.
And the cost to get this whole operation off the ground? About 30,000 rupees. That is literally all the startup funding you need to launch a small-scale farm that can pump out 100 to 150 kilograms of high-quality larvae every single month. Because the startup and operating expenses are so low, your profit margins stay incredibly high.
Oh, and I haven't even mentioned the best part yet. This entire process, it's zero waste. Think about it. The larvae eat the garbage, and then their own waste, their excreta, transforms into this premium natural fertilizer. So you sell the protein to livestock farmers, and you sell the fertilizer to crop farmers. Even the water you use to wash the larvae can be used to water plants. It is a win-win-win. Section 6. Future of Sustainable Agriculture. Empowering the next generation of farmers. Looking ahead, insect protein is rapidly moving from this quirky niche idea into a genuinely vital pillar of global food security. I love this quote, "Insect protein farming is not just waste management, it is a modern, lucrative solution to the global food supply challenge." By treating this as a serious, tech-driven agribusiness, we can actually start reducing our reliance on commercial feeds that are just destroying our ecosystems.
And this is a massive opportunity for the next generation. It creates incredible youth impact in agritech. We're talking about new local jobs, the adoption of sustainable farming tech, and super low barriers to entry for young entrepreneurs. Instead of being stuck chasing a traditional corporate job, you can step right in, build a highly profitable agribusiness, and actually protect the environment while you do it. So I'm going to leave you with a thought to chew on. If a simple little fly can help solve our municipal waste crisis and secure our global food supply, what other amazing natural technologies are we completely overlooking right now? Thanks so much for joining me for this explainer. Keep learning, stay curious, and remember, sometimes the absolute best solutions are literally buzzing right in front of us.